Hi guys, so we are continuing with our look at exploring statistical arbitrage opportunities using a machine learning strategy. So we are going to be using a machine learning strategy, and this was published in Computational Economics and in 2022. And the authors are written there. It was accepted on the 17th of July. 2021. So what are we doing with this paper? We are not we are simply saying, what did they do? We want to do it as well. That's all we are saying here. We want to be able to do it after understanding what they did. So that's sort of like replicating the paper, but we are not in any way criticizing what they did. Maybe we'll do that later, but at the moment we are much more concerned about learning the method that they implemented. So without wasting much time, let's try and move on. I know that in the previous video we actually said, look, now we are going to get the data, and no, there are still like 2-3 more things that we need to discuss before we actually go to the experiment side of things. So one of the things that we need to clarify is this M spread, because they use this term. It is a decentralized price spread. We talked about spread. We said, look, there is an ask price and a bid price. And the difference between the two is what we call the spread, right? That's what we call the spread. And for those of you that might say, what is an ask price? But this is a trivial question, actually. So when we talk in terms of finance and economics, the bid refers to the highest price a buyer is willing to pay to buy maybe a specified number of shares or stock at any given time. And then the ask price refers to the lowest price at which a seller will sell the stock. So the bid is the highest price a buyer is willing to pay, and then the ask is the minimum price which a seller is prepared to sell. So the bid price will almost always be lower than the ask, the offer price. All right. So the bid will always be lower than the offer price. So having said this, that's the spread. And from the formula that we are given, we are now going to say, look, the difference between the ask and bid at any time t is this one. So this is the difference between the ask and bid at any time t. All right. And then so it means that at time t1, 2, 3, 4, 5, we will be having epsilon 1, epsilon 2, epsilon 3, epsilon 4, epsilon 5, and so on. All right. And then we take these and we average them, and then this becomes their average. So if you look at this now, this is the difference between, so this will be epsilon 1 minus the average, epsilon 2 minus the average, and epsilon 3, and so on. This is like the deviation of the spread, the deviation of the spread from the mean of the spread, something like that. All right. So we have got the true values of the spread at any time t, and then the mean value of the spread, and the difference is the deviation. It's not the standard deviation, it's just the deviation. Okay. And then minus the cost. Now, in order for us to avoid overestimation, we have to remove the costs, because these costs, when we are signaling, we don't want to include them. All right. So we are not going to be including the cost. So we are going to remove the cost of trading. So we remove the cost of trading. So if the spread was 5, maybe the mean was 3, it's going to be lesser if we remove the cost, which is 1 in this particular case. It's just a constant. And then we are also going to be interested in the thresholds that we are going to set. So the authors actually set thresholds for opening, closing, and stop loss. So after finding these deviations, they then moved on to finding the standard deviation. standard deviation. But then this standard deviation is found in our Gauge model, where we have got the variance squared, right? We've got the variance squared, and if we take the square root of the variance squared, we get our standard deviation. So now we are simply saying, look, we are interested in lambda of the standard deviation, lambda 1 of the standard deviation, lambda 2 of the standard deviation. So it means that we allow it to deviate, but to a certain value of to a certain fraction of the standard deviation. All right, so we close when we reach a certain fraction of the standard deviation, and then we open when we reach a certain fraction of the standard deviation. So this is the standard deviation that we've got, right, that we've found. And then we are simply saying that this, because the standard deviation is our um, acceptable difference, distance from the mean, if we look at it from that particular point. And then because we are talking about mean reversion, remember, and if we get to this point, maybe we open, maybe we close, we get to this point, maybe we open, maybe we close. So this is what the thresholds are all about. They are just trying to limit, and in their limiting, we are going to use them now in the supervised, in the machine learning strategy that we have got here. And the machine learning strategy that was used in 3.2, so in 3.2, that's where the machine learning strategy is. That's where it starts, machine learning strategy. Right. So if you look now, they're simply saying that if we happen to have the M spread, which is what we were finding here, okay, if the M spread is such that we have got this relationship, so the M spread must be between these two guys, and also between these two guys, then we are going to open. All right. So when we have got 1 here, which means that label 1 indicates occurrence of arbitrage opportunity. So arbitrage occurs where the label is 1. And then when the label is 0, what must we do? No arbitrage opportunities, and closing action should be taken. And as for -1, is far beyond the threshold, implying that the risk is relatively high. It would lead to losses, and we have to stop the losses. So it is a stop loss behavior has to be taken. So this is what we also did when we were using co-integration. Remember, when we were using co-integration, our trading rules were these ones. But if you look at this, and so if you look at this one here and this one there, these two guys are the same. They mean the same thing, all right? And then you look at this one there and this one over here, these two guys, they talk about exactly the same thing. So you find that this is for reverse opening, okay? This blue one is for reverse opening. So it's for reverse opening there. And the red one is for opening, just the action you must take is just to open. So you are now seeing that there is a relationship between what was said earlier on. They didn't change this trading strategy that they used earlier on in table 1, and they are still using the same trading strategy if you look at it very carefully. All right. So these are the things now that we have gathered. Now we have got our trading strategy, trading rules well set, and we are realizing that these guys, they didn't change their trading rules at all. They are still the same. And all that we need now is, after we find this, we using the labels to indicate trading signals, opening, closing, and stop loss. The arbitrage opportunities exploration are translated into a multi-classification problem, which then provides a practical setting for machine learning strategy in statistical arbitrage. So we have got this. How did we get here anyway? First of all, we had our two stocks, ET and FT, right? So this is the prices of the assets, ET and FT, and then we concatenated them. So we concatenated them, and we now have this set XT. So XT is the concatenation or set of prices of the two assets that we're having. And then so that we get this YT as output. So all we did now is establishing a relationship between the two assets by concatenating them, and then now also describing using a piecewise function our output so that we can detect the results of arbitrage opportunities. So this is the setup that is needed. And this is the setup that we can modify, come up with our own if it is possible, and make some few modifications, depending, of course, on. So the modifications don't start from there. You can start by defining your own M spread depending on the data, the level of accuracy that you seek to achieve. So that is all I have to say on this part. And then, yeah, I think this is quite clear.